Hello, welcome back to Sushi Live Noding. In this episode, I'm going to kind of try to create some kind of stacking of like a sphere, or maybe in real life, maybe it's like a gumballs. So it's kind of like a pyramid that you want to stack and to create a pyramid, but you do it using some kind of algorithm, but using nodes. So let's just get started. I'm gonna be using Sverchok. Um, and when we are talking algorithm and using nodes, it's normally slightly different than actually trying to code everything. So in this case, really, if you have like a stack of a gumball, if you imagine that maybe just like 4 levels, um, the very bottom one probably just made up of 4 by 4 gumballs, right? And then the second one goes up a little bit. It's gonna be made of 3 by 3, and then the next one is gonna be 2 by 2, and the last one will be nothing, just one. So this, if you stack these balls together, it's gonna create a pyramid. But you see this number is like 4 by 4, 3 by 3, 2 by 2. So it's like there's some kind of pattern going on, and it's almost like a grid. Okay, so based on that idea, we're gonna try to can just use a grid, I guess. So let's try a grid plane and viewer draw. So imagine this is like a we don't need to create the polygons. Imagine these 4 points is to generate some kind of gumballs. I will be using maybe icosphere for it. So the points of the plane is just gonna be for the placement of these gumballs. So this is 4, which is 2 by 2, and we cannot have any smaller value, unfortunately, but that's okay. We can have a 3 by 3 easily, 4 by 4, 5 by 5, and it's gonna grow and grow to create our kind of a stacking of gumballs. Okay, so the placement, the point position placement for the gumballs is the important part, but we need to stack it somewhat. Before we go and generate all this gumball, back to where we have before, just the points. Okay, so the points is important. We're gonna start with maybe 2 by 2. So these points, we already center it out, and this will grow. And if we are using like a range integer number, so range integer, of course, by default, it's gonna give you range of number between 0 and 10. So it's 10 numbers, 0 up to 9. Stepping of 1, we can start from 2 actually. This is gonna be for the gumballs, and the stop value we can adjust. So supposedly if I plug this guy in there, I was expecting the plane to kind of generate like a multiple value, but apparently it's not really doing that. It's only spitting out 1, which is only the first one. So I was thinking, okay, apparently it doesn't do the factorizations, because if I kind of generate a couple of it, the plane, it doesn't vectorize itself automatically. So in a Sverchok kind of a design structure, you can actually create factorizations using monad. So I'll cut this. This is like a normal plane, but if I go to Control G and we enter the monad modes, kind of like a grouping of nodes in Sverchok, I can plug this in the X and Y for vertices, and then the output goes out like that. So I'm not gonna worry about edges and polygon, just the points. And I will go up, and I'll call this plane MK3. I just call it plane MK3 because this guy gonna factorize, and we might need to split it as well. Now if I plug this value, for the grid, this should actually vectorize somehow. You see the grid already. It looks a little bit funkier. It's kind of like crossing, and we can see there's like 8 data here. If I use a line and kind of like increase the number of lines to 8 and look at our points, look at it. It's almost like the pyramid, because it's because this guy right here, the monad, is doing the hard work and is doing the repetition and splitting of the numbers, and it's also the number is increasing based on this guy. So this guy suddenly allows you to vectorize the data, and it works really well actually. If it's like a pyramid, you probably need to do the opposite. Maybe I'll just reverse the list here. List reverse. So now we almost have our pyramid of gumballs. Like, I mean, just like just a template position for it. Yeah, except for the top one, should be the last one. I wonder if I can just go smaller. No, I cannot. So we actually need one more to add to these points at the very top. So that should be, don't worry too much about it. I guess what we can do here, use the points and use the icosphere, or use a normal sphere. I like using icosphere because it's very simple. Here with the matrix, we need to list join it apparently. Just join all the points into a single list for Sverchok. Hopefully it works as planned. Maybe I need to apply the matrix or something. Matrix apply vertices. I think the second one. This goes in there. Interestingly, it doesn't quite work as planned. Yeah, I think oh, I know why. I forgot. We need to apply the matrix here first, of course. And join them, and then we are using this for the next iteration for our gumball. There you go. That's the plan. Seems to be working. Hide the points, hide the edges, turn on the shading. So that's what's this is the gumball that I was talking about. Of course, the spacing is really need to be adjusted. There should be like a math behind it. I'm pretty sure there's a math behind this. But there you go. That's our little pyramid gumball there. Except for the top one, of course. We need, if we want this to work, I guess we can just add one more points here, just manually on the top. But I'll have a think on that. But there you go. That's our pyramid, and we can always increase the number here if you want to make it procedurally working for us. Let's say we have, this is giving us 8. This is like 8 levels, and we have to plus 2 for this guy. I'll just use a plus 1 and another plus 1. So 8 plus 1, 9, plus 1, 10, plug into this guy. So now we can control the gumballs. So yeah, I think it's a funny thing, a funny way of thinking. It's kind of like algorithm. There's an algorithm working behind it, but since we already have the plain grid, we can do this using Sverchok pretty easily. You know, it will be requiring like a different algorithm if you want to do this all by math, some kind of formula. But I kind of like this. So once we have this guy, we can really just turn this into a rigid body, and we can kind of maybe try to make them fall by shooting like a box or other kind of physical. It's the one on the top that I'll think a little bit, and maybe I'll come back to this at some point. But anyhow, this is how you might want stack of gumballs or a sphere. So yeah, I think this should be interesting enough. Hopefully this is useful for you. Let me know what you think, and I'll see you in the next video. Thank you. Bye.